Hello everyone. Let us start a new chapter in physics, chapter 15, Some Natural Phenomena. Have you observed crackles coming from hair while combing during winter? Or hair stand on end when you touch certain objects or while wearing a sweater as well? The reason behind this is static current. Electricity or current is energy that comes from positively or negatively charged particles, that is protons and electrons. Either it hang out on the surface of a material called a static electricity, or they move through the material dynamically called as dynamic electricity. But how do those charges get on the surface? Physically contacting two objects, that is by friction, allowing the electrons to hop from one object to another, and that is how charges get there on the surface. When two surfaces are rubbed together, there is friction between them, and friction is a resistance against the movement of an object as a result of its contact with another object. So when you rub the plastic comb along your hair is resisted the movement of the comb and slowed it down. The friction between the two surfaces can cause electrons to be transferred from one surface to the other. Let us understand the structure of an atom first. All atoms have a nucleus which contains protons which are positively charged and neutrons which are neutral. The atom also contains electrons which are negatively charged that are moving around the nucleus in specific orbitals. And atoms are normally neutral because they have the same number of positive charges as negative charges. So the charges balance each other out. All objects are made up of atoms, and since atoms are normally neutral, objects are also usually neutral. So what happens when you rub the comb against the dry hair? You know that the hair and the comb are neutral initially, and due to friction, transfer of charge, that is electrons, from hair to comb takes place. So when an object loses an electron, it attains a net positive charge. That's why the hair will be attaining net positive charge. And since the comb is receiving the electrons from the air, the net negative charge of the comb increases. And you also know that the opposite charges attract each other. That is why when you comb your hair with a plastic comb, your hair stands on end and makes crackling sound. Similarly, the comb can also attract bits of paper as well. The similar observation is seen when you rub a balloon against your hair. The balloon will be attaining negative charge. So when two balloons are rubbed against your hair will be losing electrons, your hair will be attaining positive charge, and the balloons will be attaining net negative charge. You know that like charges repel each other. So when two balloons are brought closer, they will be repelling each other. As soon as the balloon is brought near to your hair, the hair is attracted towards the balloon because unlike charges attracts. Even the balloon can be sticked against the wall because unlike charges will be attracting each other. The existence of static electricity has been known since ancient time, that is by Greeks, who has noticed these things during 500 BC itself. That is, while polishing amber with a silk, the amber will be attaining a net negative charge because it will be gaining electrons from the silk, and due to this, it can temporarily attract bits of straw or feather as well. The word electric is derived from the Greek word for amber, that is electron. Static electricity, as you know, is nothing but building up of charges over a surface. When electrons transfer from a charged object to a neutral object, we say that the charged object has discharge. Discharging can take place when the objects touch each other or when they are brought close, but not by touching. How does electrons transfer from one object to another by touching? Let us understand this by means of an electroscope. It is a device that is used to detect electric charges. Let us see the construction of an electroscope first. It has a glass flask with one hole rubber stopper having a metal knob that is connected to the metal rod, which is having two metal leaves at the end. In an uncharged electroscope, the leaves are straight. When a charged object touches the metal rod or the knob, the charge travels through the metal rod to the leaves and the leaves repel each other, indicating the presence of current. You know that when a glass rod is rubbed against a silk, it will attain a net positive charge. As you touch the metal knob with a positively charged glass rod, the free electrons in the leaves are attracted by the glass rod. You know that when an object loses electrons, it will attain net positive charge. So the metal rod and the knob will conduct these electrons out of the electroscope to the glass rod, and the loss of the electron causes the leaves to attain positive charge and they repel each other as like charges repel. As soon as you touch the knob, the charges get discharged to the earth through your body, and this is called as earthing. Now let us see how does electrons transfer from one object to another without touching. When the two objects come closer, the electrons move across an air gap. They can heat the air enough to make it glow, and this glow is called as spark. Small spark jumps from the finger when your dry skin is rubbed against your clothing or after walking across a polyester rug or a carpet. If you're touching a metal equipment or a metal knob, the sparks jumps from the finger. Such sparks really does not cause any electric shock. They simply startle you. The pain felt is from the heat caused by the electrons jumping the air gap, and the noise made from such a spark is a snapping sound that is caused by rapid heating of the air. The similar effect is seen during lightning also. The largest sparks are seen with lightning bolts which occur during thunderstorm. Lightning is an electrical discharge caused by imbalances between storm clouds and the ground or within the cloud themselves. During a thunderstorm, due to friction, the top of the cloud becomes positively charged while the base of the cloud becomes negatively charged. Once the difference in the charge between the regions becomes great enough, electrostatic discharge happens. That is, it becomes possible between the cloud and the earth. The connection is made and the protons rush up to meet the electrons. You know that opposite charges attract each other. It is at that point that we see lightning and hear thunder. A bolt of lightning heats the air along its path, causing it to expand rapidly. And thunder is the sound caused by rapid expansion of the air. In order to discharge extra electrons safely from an object, we must earth it, and this is called as earthing. Earthing means that we connect the charged object to the ground, that is earth, with an electrical conductor so that extra electrons can escape along the conductor and it enters the earth. Since earth it is so large, the extra charge does not have any overall effect.